We have a fantastic line of speakers for both of these events. Please check the website for more details. Data Ops, future-proofing your data platforms, all about increasing the industrial strengths of our data platforms. That's a virtual event on February 17th, 10 a.m. to 3 p.m. Australian Eastern Standard Time. And in April 6th and 7th, we have Advancing AI, a 2-day physical event in Melbourne, which is going to be around finding more use cases for AI, increasing the adoption, increasing the use cases, all within your organization. I'm super excited for these two events. I hope to see you there. I wanted to say a big thank you to our sponsor, Talent Insights. Talent Insights are Australia's leading data specialist recruitment business. They are experts in recruitment strategy and delivery for analytics and data teams. They are the go-to recruitment business for all your data roles in Australia, and they can help both with permanent hires and short-term project-focused data resources. I've used Talent Insights in the past, and I've always found them fantastic to work with. Visit them at talentinsights.com.au. So the 5 trends, I'll give you the 5, and then we'll expand on each of them. So the first 2 are around operationalization of our practices and creating sort of industrial strength systems, bringing more automation and better processes to different parts of the value chain. So the first one is machine learning operations, or ML Ops. ML Ops is creating systems that can serve machine learning models at scale and at speed to get value and to help us with the advancements. So that's how the macro trends feed into these top 5 trends in data analytics and AI for 2022. So MLOps gives us sort of multiple components. It's the creating systems that are reliably providing predictions at speed and at scale on the models that we've created. It needs as an input data prepared at speed and at scale. So that usually starts with the feature store that needs to be maintained, and that new data needs to be processed and be ready for the ML algorithms to consume. So it needs to come in a feature store. Generally, then we have a model store, which is where we're keeping all the models that we have for our different use cases. And in the model store, we want to have monitoring on how the algorithms are performing in terms of their predictions that they're providing and the recommendations that they're providing, but also monitoring the speed at which they're providing those recommendations. And then ideally, we want to have a system that is able to retrain the algorithms as the metrics start to decay. And that needs to be done ideally in the first place in an automated manner. And then it needs to be checked whether, and the check, what I mean by that is having kind of like a champion challenger approach, where there's a champion model where we know that this is the best model that we have so far for this particular use case. But then if we need to create a replacement model, and then we want to do that automatically, we need to train that model on a set amount of data that usually needs to be predefined, and then we need to test and validate that model with data that needs to be usually predefined. So then you know that the test and validation data is obviously different to the training data, but it gives you the test and validation data gives you metrics that you can compare the champion model with this challenger model to see which one should be the new champion. So should the reigning champion continue on, or is this challenger going to overtake the champion? So that can be done, that piece of the retraining, and that can be done through, for example, AutoML, techniques and approaches, or it can be done by taking the old model and retraining it, or testing new hyperparameters as kind of like more thinking more done by hand in that sense instead of AutoML, or it can be done by people, by the data scientists trying to find new methods, new algorithms, new approaches to create a new model that then it can go into this part of the system to be tested as a new challenger versus to be tested against the existing champion. And for most people, or I should say maybe a key part here is that there's multiple ways, multiple metrics to look at when trying to evaluate the effectiveness of a model. So it's easy to think about accuracy and that a more accurate model should always win. But sometimes you have, say, an imbalanced classification problem, where if you think about fraud, for example, where 99.9% of transactions are not fraud and like 0.01% are fraud, for this example. So if you wanted a classifier, if you wanted a model that was 99.9% accurate, all the model has to say is that every transaction is not fraud, right? So it's missing all of the fraud, not even having a go at picking it, but it's 99.9% accurate because 99.9% of transactions are not fraud. So that's definitely not, so that means that accuracy is not the only way that we want to measure the effectiveness of algorithms, of models, especially when they're in production, especially when it's automated. And we want to create metrics on a use case basis in order to understand how, in order to understand the value that the algorithm can actually provide once it's in production. Then we want to, if the algorithm passes that test and becomes the new champion, then what we want is ideally a staged release. So what I mean by that is and we definitely heard this from a lot of guests this year, particularly this component. Most of these components throughout the year in different conversations, but this component, what people are doing is when there's a new champion model that is being released in production, they generally start that new champion by giving it a small percentage of the data. So it might be 2% or it might be 5%, and then see how it goes with that data flow. And then as the confidence increases, then give it more of the data, 10%, move it to 20%, move it to 50%, and give it kind of like that stage release, which is something that I really enjoyed to hear and to see that it's happening in the industry. And for that, obviously, what you need the metrics to track how well the model is performing, to provide feedback. You need to know what data is being used against which version of the model at what time. So then you can do the evaluation and provide feedback at the end to close the loop. So then the algorithm continues to learn. And then these predictions need to be served at scale and at speed to the end users, as we spoke before in the macro trends. So this is kind of the MLOps space. And MLOps, there's multiple ways that organizations today are organizing themselves to deliver this capability. Some organizations that we spoke with this year, they told us that they have one ML product team that, Kendra Vant put it really nicely. She said our ML, she's from Zero, and she said our ML product teams have everything they need within the team, soup to nuts. So everything that they need to be able to get the data, prepare the data, create the models, productionize the models, get it to users, increase the usage and adoption, everything in the one team, and everyone works together to create those ML products and get them used and get the value from them. So that's one way to organize it. And in our discussions, leaders definitely said the way of organizing these teams is horses for courses. So not one way is going to work for everyone, but multiple ways are available because the needs of different organizations are different. So one way is having ML products, soup to nuts, everything together. And it's kind of like, they didn't express it like this, but it's kind of like you build it, you productionize it, you maintain it type approach. Ivan also from Rocht, he also mentioned that they have their motto, actually, he mentioned it like this. Their motto is you build it, you productionize it, you maintain it. So the idea is to have people working across the data science space around creating the models and creating the product, and then moving on to the machine learning engineering space to be able to serve and productionize those models, put them into production to be able to serve them to customers. And then, as we spoke about, we also need the third piece, which is the adoption, the change management, the marketing. That is a critical component that is often overlooked. So just as a reminder. So we were talking about ways that organizations structure their MLOps teams. Sometimes they do it all together, and sometimes on the other end, we have large organizations like we spoke with Woolies X, which is the data science and innovation hub of Woolworths. They said that they have separate teams. So they have a data science team that creates the ML product, and then they have an ML engineering team that productionizes the products once they've been created by the data science team. So there's a handover component there. And I should have mentioned before that MLOps and ML engineering, they, as a practice and as a capability, they leverage heavily from DevOps, from the DevOps world, from the software engineering world, in terms of being able to do continual releases, continual deployments, and continual integrations. And then that comes from the DevOps world. And then we, as a community, we add the continual testing to be able to retrain models as new data comes in, so models don't go stale. And sometimes that retraining is done on a time basis. So you can retrain your models every week or every month or every day if you have the volumes and things are changing that much. So it can be done, the retraining can be done on a time basis. Other times it can be done on demand and based on the metrics that we were talking about before. Metrics that you track the model performance, and then when those start to decay, you can try an automated retraining. And if that doesn't work, then it needs to go back to the data scientist for the model to be retrained, or for a new model to be created, because sometimes things change that drastically because the world is ever changing. Customer expectations and the way that customers work and live their life, that's continually changing, and you can have big events like a pandemic that definitely makes us all throw a lot of models in the bin, or at least put them on pause for quite some time. So this trend one out of the 5 trends that I'm giving you that are shaping ML and AI, data analytics and AI in 2022. This first one is MLOps, which includes ML engineering, which is essentially ML engineering is the way to productionize, or is the job title for people who work in MLOps. They are the ML engineers, and the engineering component comes from software side and the cloud side to be able to productionize these products and be able to use them and deliver them at scale and at speed. And this and then the ML engineer comes almost from a fusion or a combination of data science and data engineering, plus a bit of cloud engineering, and that's something that is coming up in all different parts of the industry. That is kind of like maybe the rise of engineers might be a better way to do it. But what better way to term it? The rise of engineers in the data space. So we've had, data engineers in the last 5 years. Now we have analytics engineers, which is another part of another trend, which I'll talk about. Analytics engineers, machine learning engineers, and obviously we need to be working very closely with software engineers and cloud engineers. So there's this now almost like a suite of engineers that work in the data and ML/AI space. And as a result, this is a good segue. That as a result, Data Futurology, we're putting on an engineering summit next year, about halfway through the year. It might be May or June, and that's going to be discussing the advancements that are done by all these engineers that we just spoke about. So it's gonna cover machine learning engineer, everything that's happening there and how to do it better, ML engineering, data engineering, analytics engineering, software engineering when it comes to the data space, and cloud engineering, which are all critical components to take these technologies to fruition, to have them operating at scale and at speed, to increase the advancement and to get more value from them. So we're going to have an event that focuses on engineers, and this rise of the engineers in the data space is a theme that you'll see in a couple of these trends. So, but to finish off the MLOps side, we're talking about the fusion or the combination of data science and data engineering. What I've seen in the market this year is that data scientists are learning and want to learn data engineering skills. The data engineers are learning and want to learn data science skills, and that this blend is becoming more and more real in the market, because you need both sides of these skills to be able to productionize and get value from these algorithms and from these technologies. And it's been such a big market trend that I've even seen university degrees that are I saw a master's from a Sydney university, that it was Masters of Data Science and Engineering, and I was like, awesome. That's exactly what we need. That's exactly where the market's going. So definitely, and during the pandemic, I saw many data scientists and many listeners that you guys were working quite hard on your cloud engineering skills, on your engineering, software engineering or data engineering skills, and through that, building up your machine learning engineering skills, which is fantastic. And that's definitely the way the future is going. Not that ML engineers, they're not going to replace data scientists. There's always going to be a place for data scientists to create kind of like the new products. And then the ML engineer is going to help with the delivery side. So this is all encompassing the first trend that I have for you today on trends that are shaping data analytics and AI for 2022. So now let's go to trend 2. I'll just make a note here. So trend 2 is quite closely related to trend 1. So trend 1 was MLOps and ML engineering. And if you think about it, that's in the later part of the value chain. So that's typically starting from the feature store, where the data has been prepared at scale, and then as we spoke just then, going through the feature store, model store, being able to serve those algorithms at scale, retrain them if necessary, and then get them to users. So before that, what comes before that is trend number 2, which is data ops. So operationalizing the data space. Also quite a big area, which involves data ingestion, data processing pipelines, obviously data warehousing, and data visualization. So all of that but being done in a way that is industrial, or that being done in a way where the systems are at an industrial strength level. So they're much more reliable. Increasing that reliability is a key component of the ops part. Increasing the visibility and the monitoring, and being able to work in a more of a DevOps manner in this space. So let's dive into that a bit more. As organizations have increased their dependency on data, and a lot of organizations for some time have been saying, data is key to us. Data is our key asset. It's critical, etc. Data is the new oil, and all those phrases. So organizations want to be using data, but then what we found in most organizations, or in a lot of organizations, maybe most, is that the way that the data processing pipelines and the data warehouses, the way that those were built had a lower expectation on them in terms of availability, reliability, and monitoring than what you would expect from a core business system. So a core system, it has high uptimes, high reliability, lots of monitoring. If something fails, generally you get alerts immediately because it's business critical. The shift that data ops is helping us make is to take our data processing pipelines, data ingestion, data warehousing, and BI, and making those business critical, and increasing the reliability, having more uptime, having really good monitoring. So then, if and when something fails, you know exactly which part failed, and you're able to rectify it soon. And you have backups and good CI/CD practices in order to do that. Now, for a lot of people, and definitely for some of the old school people in the industry, and I mean old school in a good way, old school like me, we've thought that's having reliable data processing pipelines and data warehouses, having them reliable at an industrial strength level, where with good monitoring and good visibility, that's just called like doing a good job. Like a lot of old school people just see that as a almost like a hygiene requirement that's basic, and I think that's true. But before, we didn't have the language, the focus. We weren't discussing the methodologies. The methodologies was more focused on the data preparation, on what's being done in the pipes, and how the data is stored, and what are the structures and the schemas, and how to optimize, say, our SQL and things like that. But we weren't talking about what does it take to create these systems take them to an industrial grade strength to give us the confidence that they are, or at least can become, business critical systems that everyone or large portion of the business depends on for their work on a day-to-day basis. Like that's the crux of it, taking it to that level of reliability, of availability. So in this space, so this is what's essentially being called data ops, from the data ingestion, data processing pipelines, data warehousing, data lakes, and then being able to serve those into feature stores, which is where MLOps starts, and then also being able to take the data and put it into dashboards and business intelligence applications, also in a reliable way with good uptime and good auditing and monitoring and visibility and etc. So super important components in this space. We've seen the rise of the analytics engineer, who are using software engineering practices in the data ops space or in the data space, data preparation space. And the analytics engineer is encompassing this whole breadth from ingestion to the feature store and and visualization layer. And they're developing their software engineering skills, their cloud skills, to be able to create these reliable systems. And we've seen a lot of good tech come up in this space, and one of those which has become really popular, we definitely use it as well, is DBT. So for the people who don't know, it stands for database tool, and it helps you do a lot of the data engineering work by orchestrating your SQL and then being able to run it and do that in a software engineering manner. But we've obviously, and definitely a lot of people as well, have had to invest in monitoring tools and visibility tools, and in better using our cloud data warehouse software to be able to leverage the strengths that it has and cover the gaps that it doesn't provide, to be able and doing all this work to be able to create reliable and well orchestrated systems that are business critical. And there's definitely a lift for most of us in the industry. It's been it's one of the trends that is going to continue to shape the industry, definitely for next year, for 2022 and beyond. It's my prediction that this is an area that's going to gain more and more traction and speed, as similar path as what we've seen with MLOps. MLOps is a little bit further ahead, but data ops is very necessary, and data, the innovation in the data platform space has been incredible. So there's a lot there for us to cover, and we have a data ops summit coming up. So this is going to be Australia's first data ops summit, which we're super proud to bring you, and that's coming up in February. So February 2022. And we're focusing on data platforms, on how DevOps integrates with that, how to create these business critical systems. What are the different components that you need, which a lot of them I just mentioned, but we're going in at depth in terms of how this data can be ingested, captured or ingested, processed at scale, made available to the business, being made available to machine learning models, and being made available to visualization tools, and have those visualization tools help people make decisions throughout the organization. So that's all in the data ops space. And watch out for our event. It'll probably be mid-Feb next year, mid-Feb 2022. Come and check it out. It's likely to be online, so sign up on the website because it's going to be a great one.
Thanks for watching this video all the way to the end. I hope that you got a lot out of this discussion. And if you're watching on YouTube, please like and subscribe to the channel so more people can find out about the challenges that leaders have in the analytics and AI space. And that's what we're trying to share in Data Futurology. So please like and subscribe. And if you enjoyed today's episode, please tell your friends. Thank you so much.